Hey everyone, it's Pennis Data Diaries again. Today I want to start with a new series on linear algebra with Python, and especially with SymPy or the symbolic Python library. And I have to, of course, first shout out to MIT's awesome introductory linear algebra series led by Professor Gilbert Strang, which is an inspiration and which I assume many of you have already seen. If not, definitely check it out. I will link it in the show notes below. Today I want to start by discussing Gauss-Jordan Elimination, which helps you to identify the inverse of a matrix. And we're doing this with SymPy. So first of all, I'm showing you this Jupyter notebook over here, and I'm starting by importing the SymPy library as SP, as is the convention, together with some config libraries so that I can print it out in the Jupyter notebook. And I'm initializing the pretty printing over here and loading a sample matrix. So let's print out the sample matrix first of all. So this is what the matrix looks like. It's a 2x2 matrix. It has these two columns, 1, 2, 3, 7, and we want to get its inverse. To do that, we use the Gauss-Jordan elimination. And the first step in Gauss-Jordan elimination is to attach the identity matrix behind the initial matrix. So we can do that in SymPy by using this command here, row join, and then we say SP, which stands for SymPy, .I, so the identity, and we have a 2x2 identity attached to it. So let's do that. You see, we have the initial matrix over here and the identity matrix over here. So it's the augmented matrix. So the next step would be to eliminate this entry over here, and we can do that by subtracting 2 times the first row from the second row. And the syntax for this is we use A augmented and say it equals A augmented 1, colon, minus 2 times A augmented 0, colon. So in SymPy, we start counting with 0. So the 1 over here actually means the second row, and the 0 over here means the first row of the matrix. When we do that, we print it out, you see what happened. This entry here has been eliminated. It's a 0 now. And also, we're keeping track of the modifications in the before identity matrix. So over here, we have a -2 now, which used to be a 0. So we're saying -2. And the next step would be to then subtract 3 times the second row from the first row. So let's see what's going on over here. After we subtract this, we see that we now have the identity over here. See, this is the identity matrix. And over here, we have 7 minus 2, minus 3, and 1, which actually is the inverse matrix. So this is A inverse over here. And in the last step, we only want to show it. So I can extract A inverse from here. I'm just saying, give me A augmented, but only give me everything after the second column. So starting from here, I'm removing the identity over here. So this is the part that we wanted, and this is what's the result over here. So this is the calculated inverse matrix. Of course, I'm just showing you these steps for educational purposes. If you want to just get it right away, there's of course a command that you can use, and it's called .inv for inverse, and it will directly print out this matrix for you without you having to go over all of these steps. But I think going through this process manually using SymPy, first of all, helps you to memorize the SymPy syntax and also the Gauss-Jordan elimination steps. So I hope this was useful for you as well. See you again back on my channel.